does changing the position of hypothesis and conclusion in a conditional statement reveal? How about negating both? Consider the following statement. If a polygon has four sides, then it is a square. This statement is false because there are other quadrilaterals that are not a square. Some of these are a trapezoid, a rectangle, a rhombus, and another trapezoid. Switching the position of the hypothesis and conclusion of this statement, we have: if a polygon is a square, then it has four sides. The new statement is true in this case because we know square has four sides. Such a statement is called the converse of the given conditional statement. To express the converse of a conditional statement, simply interchange the hypothesis and conclusion. In general, in the statement if P then Q, the converse is if Q then P. This is denoted as Q implies P. For example, state the converse of the following true statement. If x is 3, then the square of x is 9. The converse is if the square of x is 9, then x is 3. The converse of this particular statement is false because x can be -3. The negation of a statement is its opposite. Of course, the negation of a true statement is a false statement and vice versa. For examples, negate the following statements. 4 is an even integer. The negation is 4 is an odd integer. 5 plus 2 is greater than 6. The negation is 5 plus 2 is less than or equal to 6. 10 is a rational number. The negation is 10 is an irrational number. Negating the hypothesis and the conclusion of a conditional statement is the inverse of the statement. In general, in the statement if P then Q, the inverse is if not P then not Q. This is denoted as the negation of P implies the negation of Q. It can also be written as for example, state the inverse of the original statement. If x is 3, then the square of x is 9. The inverse is if x is not 3, then the square of x is not 9. The inverse is also false as the converse of the original statement. What if we take the converse of a statement and at the same time negate the hypothesis and conclusion? Using again the original statement, if x is 3, then the square of x is 9. We have the new statement, if the square of x is not 9, then x is not 3. This statement is the contrapositive of the original statement above, and its truth value is the same as the original. To express the contrapositive of a conditional statement, interchange the position of hypothesis and conclusion. and negate both of them. In general, in the statement, if P then Q, the contrapositive is if not Q then not P. This is denoted as the negation of Q implies the negation of P. This can also be written as